Pavement design. A highway pavement is a structure consisting of superimposed layers of processed above the natural soil separate, whose function is to distribute the applied wheel loads above the wheel loads to the subgrade. This is the typical structure of pavement. We have normally four courses: subgrade, that is naturally or compacted soil layer or ground layer; subbase, here we can use the GSB, granular subbase course. Next is base course, here we can use the WMM or WBM, wet mix macadam or waterborne macadam. Next, last one is surface course. Surface course means it can be two types: binder course and surface course, or normally we will use the surface course. In flexible pavement, it will be bituminous course. In rigid pavement, it will be concrete surface. What are the requirements of the pavement? How we have to construct the pavement, or objectives of the pavement? Whenever we are designing the pavement, we have to keep these points in our concern. First one, it should have the sufficient thickness to withstand the load. Whatever the load you apply on the pavement, it should be safe to be sustainable by the subgrade soil. Whether it will sustain the load or not, we will check the CBR value. Next, structurally strong to withstand all types of stresses imposed upon it, whether it is the compressive stress, flexural stress, that is, if the bending takes place, all types of stresses should be withstandable. Next, adequate coefficient of friction to prevent the skidding of the vehicle, and smooth surface to provide the comfort to road users even at high speed. Basically, both the points are about friction only. Here, we should provide the friction such like that there should not be any skidding. That is, we have to provide the friction, as we already studied, we have to provide a friction of 0.15 for lateral and 0.35 for the longitudinal. If you provide the more friction, what will happen? Resistance will be more, you may not get the higher speed. So proper friction should be provided. If you provide the more friction, then the surface is not smooth, there will not be comfortable to the road user. Next, it should produce the least noise from the vehicles. Due to the rubbing action between tires and the surface, whether it may be aggregate or it may be CC pavement, it will get produced, some noise will get produced, it should be minimum. The surface should be dust proof, especially for the shoulder construction. You have to properly compact the shoulder such like that there should not be any dust on the pavement to avoid the skidding of the vehicles. Water resistance, impervious surface. Your surface should be impervious. If water deteriorates to the subgrade soil, or if water penetrates to the subgrade layer, then your pavement will be gone. Long design life with low maintenance cost. That is, it should be cheaper and it should be sustainable for longer life. Next, pavement will be basically divided in two types: flexible and rigid. Again, we have a semi-rigid, half flexible and half rigid. Flexible and rigid pavement differences we will study. Here it is based on the load distributing characteristics of component layers. We have the subgrade aggregates, force aggregates, fine aggregates, soil layer, different aggregate layers we have. Based on that, we will design the flexible pavement. Rigid pavement is basically your slab. What will happen? We already know concrete is good in compressive strength. Flexible pavement, if the compressive strength increases also, then also it may fail. But rigid pavement is very good in compression. That's why we have to design based on the flexural strength. Whenever the wheel passes on the pavement, the slightly bending will take place. So to study that bending strength, we have to look at the flexural strength of the concrete, which can be increased by the reinforcement. Life of the pavement here is very low, 10 to 20 years max. Here life of the pavement is up to 40 years. Even if you maintain it good, it may come up to 50 to 100 years. Typically, flexible payment will be designed for 15 years and rigid payment will be designed for 20 years. Here, more oftenly maintenance is required, especially for the surfaces, for the formation of the potholes, undulations, rutting or anything. Here, the maintenance required is very less. Initial construction cost is very low. Construction cost is high. Here, maintenance cost is high. Here, maintenance cost will be low. It is good for stage construction. Suppose if you have get the thickness of 700 mm, we can construct in the first stage. Due to the lack of the budget, we can construct up to 400 mm, and remaining 300 mm can be constructed whenever we get the budget. But if you get the whatever is the thickness of the rigid pavement, even if it is 200 mm, we cannot construct 150 mm because it is the slab thickness. Whatever the designed thickness we have to construct at single stage. Here already I've told it is the low flexural strength. We do not use any reinforcement, so the flexural strength will be less. Here the flexural strength will be high. Immediately after 24 hours, we can use it for the transportation. Why? To dry the surface or for the settlement, the bituminous course required only 24 hours. Within 6 to 8 hours, the bitumen will get hardened. But for roads, it is normally required 14 days. Even if we use the rapid hardening concrete, minimum is 7 days is required. We will study what are the flexible pavement. It is wheel loads transferred by grain to grain. Whatever the aggregates we have, through that the wheel loads will be transferred. Next, rigid pavements have the sufficient flexibility to transmit the wheel load stresses to the wide area below. Here we have the rigid pavement. The important thing is we have to study the characteristics of each layers. Soil subgrade, both side it will be same. Subbase course, we don't have the subbase course in the rigid pavement. Here we can use the base course or subbase course. Any one course is sufficient. Why? The maximum load will be stresses will be withstand by the CC pavement. Here the grain to grain particle distribution will be done. Functions of the pavement layers. See, flexible pavement or rigid pavement. Subgrade will remain same. What is subgrade? It is the top of the soil, or the subgrade is the layer of natural soil prepared to receive the stresses from the layers above, whether it is the base course, surface course, whatever. It is essential that at no time soil subgrade is overstressed. Even your upper pavement layers are good. If the soil subgrade layer gets overstressed, it will fail immediately and repairing cost will be very high. If the soil subgrade layer fails, it is as good as construction of the new pavement. It should be compacted at desirable density near to the optimum moisture content. In the lab, you will check the density. Maximum dry density will check whatever the strength it will get you achieve by the optimum moisture content. Same density we have to achieve it in the soil. We have to achieve the good compaction. Next is sub-base course. Sub-base course is above the subgrade and below the base course. Its primary function is to provide the structural support to the base course and to improve the drainage property. I told it should be impervious layer, but ideally impervious layer is not possible. Whatever the water percolates to the base course, it should be gone by the sub-base course. So water should not percolate to the subgrade. If water percolates to the subgrade, it will fail. Next, base course. It is the layer of the matter immediately beneath the binder course. It has to sustain the more stresses compared to the subbase course. It provides additional load distribution and contributes to the subsurface drainage. It may be composed of crushed stone, brick batter, brick waste materials, anything. The most important is surface course. It is in direct contact with traffic loads. generally contains superior quality material, that is 6 mm aggregates and bitumen or the asphalt. Asphalt concrete means it is similar to the bituminous concrete with higher standards. We use the semi-dust bituminous concrete. Why the surface course is important? It has to sustain the maximum load. When we load distribute to the base course, sub base course, it will be get distributed in various layers. The load will be lesser, but the surface course, the maximum load will be withstood by the surface course. It has to properly distribute the load to the beneath courses. What are the function or the requirements of the surface course? It provides characteristics such as the friction, smoothness, dryness, etc. We have to provide the proper camber for the dryness purpose, friction for the proper smoothness. Next, it must be tough to resist the distortion under traffic and provide the smooth skid resisting riding surface. Distortion means aggregates, the small aggregates normally we may have seen the aggregates will come out of the road. It should not happen. It must be waterproof to protect the entire base subgrade from the weakening effect of the water. If water enters, if you don't provide the proper camber, if the water enters to the base courses, then the pavement will fail. Next, design factors. How we design the pavement. Basically consists two parts. One is mixed design of the materials, whatever the aggregates we will use, whether we will use the basalt, sandstone, granite, what is the quality of the aggregates, bitumen, based on that. Second one, thickness of the pavement and component layers. It's similar to your building designs. Here we will check the CBR of subgrade. If the CBR is higher, the strength is higher, the thickness of the pavement will be lesser. If the strength of the subgrade or the CBR value is lesser, thickness of the pavement will be higher. What are the factors affecting the pavement design? Wheel load, subgrade soil, that is CBR, climatic factors, rainfall, frost, fog, or any water table, higher water table, all those things. Pavement component materials, that is basically your aggregates, bitumen, soil, environmental factors. Next, special factors in design of different types of pavements, whether it is the flexible, then it is designed mainly for the compressive strengths. If it is rigid, it is for flexural stress. In design wheel load, the major thing for your syllabus is equivalent single wheel load. Maximum wheel load allowed as per IS is 8 tons. Previously, now it is revised to the 10 tons. The most important part for your syllabus is equivalent single wheel load.